Here's a design decision that quietly drives your Azure OpenAI bill. Do you send every request to GPT-4o, or do you route smartly between GPT-4o and GPT-4o mini? In this video, we dissect one real reference architecture, a customer support assistant, and trace how a single user message flows through a router, retrieval, and two different model deployments. You'll see why each piece exists, where it fails, and the concrete trade-offs an architect weighs when picking the right model per request. Let's open the diagram. The flow starts at API management, which handles auth, rate limiting, and token quotas. It forwards to a classifier running on GPT-4o mini that scores the request's complexity. Simple lookups and summaries stay on mini. Anything needing deep reasoning or image understanding escalates to GPT-4o. Both deployments pull grounding context from Azure AI Search before answering. Putting the cheap model in front as a triage layer is the key move, because the classifier itself costs almost nothing yet diverts the majority of traffic away from the expensive model. So what actually separates these two models? Both are multimodal and both currently share a roughly 128,000 token context window. The difference is capability versus cost. GPT-4o gives you stronger reasoning, better instruction following on complex tasks, and more reliable structured output. GPT-4o mini trades some of that reasoning depth for dramatically lower price and lower latency. As a rule of thumb, mini handles the bulk of routine work while 4o earns its keep on the hard tail. Always confirm context limits and modality support in the current Azure docs, because these specs change. The economic argument is stark. GPT-4o mini is roughly an order of magnitude cheaper per token than GPT-4o. If your classifier routes 70% of traffic to mini, your blended cost per request drops sharply while quality on the hard 30% stays high. Latency follows the same pattern, since mini's smaller size means faster time to first token, which matters for streaming chat. The trade-off is misclassification risk. Route a hard question to mini and you ship a weaker answer. Pricing shifts often, so validate the current numbers before you model your budget. Let's walk one message through. The gateway authenticates and checks the token budget. The mini classifier returns a complexity score and an intent label. The router applies a threshold. Below it, mini answers directly. Above it, the request escalates to GPT-4o. Either path retrieves grounding from Azure AI Search, then the chosen model generates a streamed response. Notice the classifier and the responder can be the same mini deployment, so you're not paying for extra infrastructure, just two calls where the first is tiny. Now the failure modes. Each Azure OpenAI deployment has its own tokens per minute quota, so a traffic spike on 4o can throw 429 errors while mini sits idle. Build a fallback. On a rate limit or timeout from 4o, retry on mini with a degraded quality flag rather than failing the user. Watch for classifier drift too, where intent patterns shift and routing accuracy quietly decays. Mitigate it by logging routed decisions and sampling outputs for offline evaluation. Treat the router as a first-class component with its own metrics, not an afterthought. In practice, you provision each model as a separate deployment with its own capacity, and you can express that as infrastructure as code. Here's a bicep fragment defining a GPT-4o mini deployment with a provisioned capacity unit. You'd declare a second resource for 4o with a higher capacity. Keeping deployment names stable matters, because your router code references them by name. Pin the model version explicitly so an upstream default change doesn't silently alter behavior, and check the docs for the available version strings in your region. To recap, don't pick one model, design a tiered system. Put GPT-4o mini in front as a cheap classifier. Let it answer the routine majority, and escalate only the hardtail to GPT-4o. Ground both with Azure AI Search, give each deployment its own quota, and build a fallback so rate limits degrade gracefully instead of failing. Your one concrete takeaway: instrument the router from day one, logging every routing decision so you can measure accuracy and tune the threshold against real cost and quality data. And since pricing and model specs change, verify the current Azure docs before you commit. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.